So when you're concerned about the graphing of the exponential and logarithmic function, you want to understand how they're related. So if you see the basic exponential graph is a to the power x graph is here. And if you find the inverse of this function, here, just so the property is, before you go to invert, your property is that here the domain is x belongs to a real number and y is greater than 0 because this is an asymptote here. Now, if you find the inverse of this function, you get x equals to a to the power y. And if you make y the subject, you get log x to the base a. So you can see that this exponential function and logs, they are basically the uh, inverse of each other. So as we know, the inverse function is basically, if you draw the graph of inverse function, it is reflection in y equals to x line. So if you draw it here, this is how the graph look like. So this is the graph of log x to the base a, and this is a graph of y equals to a to the power x. So when you're doing this topic, I would recommend that you should have a good idea about the transformation of functions. Make sure you have thorough idea about like dilation, stretches. That makes your life much more easier. So this point here is 1, 0, and this is 0, 1. Now, sometimes what happens is, if I'm drawing 3 to the power x and 4 to the power x graph. So 3 to the power 4 to the power x graph and 3 to the power x graph. So this will be the 3 to the power x graph, and this will be 4 to the power x. So same way what happen is, if you have got 3 to the power base x, this side, it is going to be slide a bit like down here, but still it cuts at 1, 0. So this will be log 4 to the base x. This will be log x to the base 4, and this will be log x to the base 3. So just remember that the graphs are very standard, and you can just find out by making sure that you understand the link that they're inverse of each other. Now, let us consider a simple question is, if you have got to sketch log x minus 3 to the base 2. So if you are sketching y equals to log x minus 3 to the base 2 graph. Now, if I know the graph log x to the base 2, I can just move the graph 2 units to the right. So if you have this graph, log this to the graph of log x to the base 2, log x to the base 2. And if I move, let's say 2 units to 3 units to the right, so this cuts now at this at 3. So here now you'll have new vertical asymptote that will also get shifted by 3 units. Sorry, this will be at 4. So this will get shifted by 3 units. So here you will have x equals to 3 as a new vertical asymptote. So this is as far as the log basic graphs and properties are concerned. Now let's take two questions that are like a little kind of tricky and challenging. And they will be like helping us to understand the entire property more in detail. So consider that I have got log 2 minus x to the base 5 plus 3. And second app is y equals to e to the power of x plus 5 minus 1. And what I wanted to do is I wanted to sketch firstly the graphs of each of them, and then sketch their inverses and also find the inverse and their respective domain and ranges. So I'm going to basically use here the basic concept of transformation. So if you have log of 2 minus x, firstly I do like this, x minus 2 to the base 5 plus 3. So if I show you the step-by-step transformation, so what I'm going to do is I'm going to sketch first log x to the base 5 graph. The graph is here, reflect across y-axis, and then move 2 units to the right. So this cuts here again. So if I move 2 units to the right, you'll have a vertical asymptote at x equals to 2, and then move 3 units up. So first is like here, this is the graph of this part. And if I move 3 units up, so it'll be possibly here, something like this. So this is the graph of the function that I want. And now what you can do is, let's say I have to sketch the inverse of this function. Of course, you can just draw y equals to x line, and you can see your inverse part will be, this part gets reflected here, something like this. And this part gets reflected here. So And as far as the function is concerned, if you wanted to find out the inverse function of this, you'll take x equals to log of 2 minus x to the base 5 plus 3. So you get, this is y here. So if you make y the subject, so it'll be log of 2 minus y to the base 5 equals to x minus 3. So if you get rid of log here, you get uh, 2 minus y is 5 to the power of x minus 3. And you get y is 2 minus 5 to the power x minus 3. And so here you can see that their vertical asymptote was x equals to 2. And here you will see that your horizontal asymptote for this exponential graph is y equals to 2. So the domain become range become domain for any general function. But this is also like just a general idea in your mind for if you wish to apply not the properties of the exponential function, if you want to apply the properties of logs to get the properties of exponents straight away. So you don't need to mug up anything. Now coming to the second example, e to the power x graph is here. And if I move 5 units to the left, so the graph is something like this, and move 1 unit down. So if I move 1 unit down, I have no idea where does this cut. So it'll be like e to the power 5 minus 1 actually. And if I move, let's say this is e to the power x, it'll be e to the power 5. And if I move 1 unit down, so it'll be somewhere here. But still, the asymptote is going to be this axis, the y equals to -1, because the graph has shifted 1 unit down. So now when you're sketching the inverse of this function, once again, you draw the graph of this. Draw x equals to -1, y equals to -1 is the horizontal asymptote. So x equals to -1 is going to become the vertical asymptote. So the graph here is going to be something like this. And so you can predict the domain and range for each of them. So now this domain will be x greater than -1. And to get the inverse function, you do x plus 5 minus 1. So interchange x with y. So x is e to the power 5, e to the power y plus 5 minus 1. So e to the power y plus 5 equals to x plus 1. And so you get y plus 5 equals to ln x plus 1. And so you get y as ln x plus 1 minus 5. So this is about the basic properties of logs and exponent as in general. Let us now kind of solve more problems and understand the properties better.